everyone, I am Snigdha Kakkar and this is my channel Accelerate AI Careers. Today we are going to solve a very interesting LeetCode problem, LeetCode 70, Climbing Stairs. It's an all-time favorite of Amazon, Google and Microsoft. So if you are preparing for FAANG companies, this question is for you. So what does this question say? You are climbing a staircase. It takes n steps to reach the top. Each time you can either take one step or two steps. In how many unique ways or distinct ways can you climb to the top? So let's look at some examples and see what does the question exactly mean. So for example, you have been given n equal to 2 in example 1, that is the end goal is to reach n equal to 2. And in each iteration, you can take either one step or two steps. So how many unique ways are there to reach n equal to 2? So either you can start using one step each time, so one step plus one step, or you can start taking just by two steps at a time and you reach the top. You might say that I could take one step in the first iteration and then I might try to take two steps, but then it goes beyond the end goal. It will take 3 steps, which is beyond n equal to 2, hence I have not taken that. And there are only 2 unique ways. Either you start by one step and then one step, or you take 2 steps at a time. So 2 unique ways to climb to the top in example 1. Now let's look at example 2. In example 2, you have been given n equal to 3 for the top. One unique way would be that from 0th step you take one step and then one step and then one step. The other approach could be that from 0th step you take one step and then you take 2 steps. The third approach could be that from 0th step you take 2 steps and then from second last step you take the 1 step. So these are the only 3 approaches. If you take any other approach, you will end up going beyond the end goal, which is n equal to 3. So I hope the examples clarify what does the question demand. This is a very classic case of dynamic programming and we'll see how to code it by using different approaches. This question is also a part of blind 75 list of LeetCode. So it's a very important question, I must say. So let's look at an example to understand it better. Now it is difficult to visualize the question just by looking at the various approaches. So I would suggest let's use a decision tree to visualize this one example. So say suppose your n is equal to 5. That is, you have been given that your end goal is 5 steps. So when you start from the 0th step, you have 2 options. Either you can take one step and reach step 1, or you can take 2 steps and reach step 2. If you take one step, then you have again 2 decisions. You take one step and go to step 2, or you take 2 steps and go to step 3, and so on. So if you reach step 2, then again you make 2 decisions. Either you take one step and reach step 3, or you climb 2 steps and reach step 4. And from step 3, again 1 or 2 steps, which will lead you to either step 4 or step 5. If you reach step 5, that is your end goal, hence it is circled here. Now, if you are at step 4, there are 2 options. Either take one step and reach step 5, or take 2 steps and reach step 6. But step 6 is beyond our end goal, so hence it is crossed out here because that is not possible. So there is only one way that you can go from step 4 to step 5 and not 2 ways. Step 5 is our end goal, hence it's circled here. When you start from step 4, there's only one way to go, that is take one step and reach step 5. Same way here. So if you see that this is happening recursively and it's kind of a depth first search where you are actually replicating the same steps at so many times. As you can see this highlighted square, starting from step 2, reaching till step 5, this is the exact replica of what you are doing here in the another highlighted square, starting from step 2 and reaching till step 5. And that's not all. If you look at this way, that you start from step 3 and reach till step 5 here, this is again replicated here. You start from step 3, reach till step 5. It's also replicated here. Start from step 3 and reach till step 5. Same ways, when you start from step 4 and reach step 5, that's also replicated so many times as you can see in this decision tree. So if you look at this way of solving the question using recursion, the time complexity would come out to be O of 2 raised to power n, because every step you are making 2 decisions and which impacts your further decisions. So that's very less efficient way to solve this problem. But you can use caching to solve this question. So you can save how many unique ways are there to go from step 4 to 5 and use that whenever you reach step 4 in the question. Or you can save how many ways are there to go from step 3 to 5 and use it everywhere you reach step 3. Same ways you can save how many ways are there to go from step 2 to 5 cache it and use it in another places where you reach step 2, and so on. This way of caching will save you a lot of time and will reduce your time complexity of the question to O of n. But is there a better way to solve this question? So the answer is yes. The dynamic programming approach is far better to solve this question. So let me explain you that with an example. Now here I have shown the previous example, n is equal to 5, and we start at the 0th step, and we take 1 step or 2 steps at each iteration and try to reach n equal to 5. That's our end goal, right? So if I am doing this question using dynamic programming, I use a DP array as shown below to solve this question. So what I do in DP array, instead of starting from 0th index, I calculate backwards. I start from the 5th index, like n equal to 5. What does it take to reach n equal to 5 if I start from n equal to 5? How many ways are there? So if I'm at n equal to 5 and I have to reach n equal to 5, there is only one unique way you can go, right? So that's why I have placed 1 here. Now if I calculate how many unique ways are there to go from step 4 to n equal to 5. Since from 4, as I have shown in prior decision tree, you can take 1 step and reach step 5, or you can take 2 steps to reach step 6, which is beyond the scope. Hence that cannot be done. So you can only take 1 step and reach step 5. So there is only one unique way to go from 4 to 5. Now for computing unique number of ways to go from step 3 to step 5, you don't have to do so many calculations. You just have to take the sum of number of ways you can go from step 5 to 5 and step 4 to 5. So 1 plus 1 is 2, and that's why those are the number of ways you can go from step 3 to 5. And this will keep on going like this. So if you have to compute total number of ways to go from step 2 to step 5, you just have to take the sum of prior two letters in the array. So you take unique number of ways to reach from 3 to 5, which are 2, and from 4 to 5, which are 1. So 2 plus 1, 3. So those are the number of ways you will have from step 2 to 5. Same ways to compute from n equal to 1 to n equal to 5. You have to take the sum from unique number of ways you can go from 2 to 5 and 3 to 5. So 3 plus 2, 5. And finally your answer is dp0, which would be the sum of dp1 plus dp2. So 5 plus 3, 8. Hence there are 8 unique ways to start from 0th index and go to n equal to 5. That's your answer. So if we follow this approach of solving our question, then our time complexity would be O of n, but our space complexity would also be O of n, because we are using an array to represent our DP. Can we reduce the space complexity? So if you see at any given point of time, to compute the number of unique ways, I just need the prior two values. I don't need the entire array. So if I have to compute number of unique ways to go from n equal to 3 to n equal to 5, I just need n equal to 4 and 5 values, and so on. So I need only 2 variables and not the entire array. So I can of course reduce this space complexity, and that's what we are going to do in our solution here. So let's dive into the coding of the solution, and if you have any doubts, you can ask in the comments. Now, as concluded in the algorithm explanation, I don't need an entire DP array to compute my final answer, that is dp0. I just need the prior two values every iteration I take. So that's why I'm going to initialize two variables 1 and 2, and I'm going to initialize them by 1 each. Why? Because if I have n equal to 5, then there is only one unique way to go from n equal to 5 to n equal to 5. And if I am at n equal to 4, to reach n equal to 5, there is only one unique way, which is one step. And this will be true even if your n is equal to 100 or n is equal to 200, irrespective of whatever end goal you have been given, because there is only one unique way to start from the last step and reach the last step, and there is only one unique way to start from second last step and reach the last step. Hence, I have initialized my two variables 1 and 2 by 1 each. After that, I'll run my loop for I in range n minus 1. Why n minus 1? Because then I will be repeating this entire process for n minus 1 times, as I have initialized only two variables. And then I will update my one variable always by 1 plus 2, as I take sum of prior two values. And then I'll update my two variable by whatever my 1 was earlier. But my 1 already got updated. So how I updated by that? So I have to store one value somewhere here, and then I can update 2 by 10. And then finally, whatever my one variable is at the end, that's what I'm going to return. And that would be my answer. So let's run it and submit. So as you can see, the solution is quite efficient. Let me explain it to you with an example. You initialize n equal to 4, that is one variable, as 1, and you initialize n equal to 5, that is two variable, as 1 again. That's how we proceed when we go backwards, okay? And we follow it for n minus 1 iterations. That's why we run for all other 4 cells here. So hence for I in range n minus 1. After that, I first store this one variable in a temp variable so that if its value changes, at least I have it someplace, okay? And I keep on sliding this window backwards. So from n equal to 4 to 5, this window slides to n equal to 3 to 4, and then n equal to 2 to 3, then n equal to 1 to 2, n equal to 0 to 1, and I always have to take sum of the last two cells. That's what I am sliding the window for. So to calculate the number of unique ways from n equal to 3 to 5, I just have to sum up 1 plus 2. That's what I have done. And I'll update my one variable itself because I'm using only two variables. So I have to override them again and again. So that's what I'm doing. So 1 plus 1 would be 1 plus 1, that is 2, and I'll update it in one variable. But I have to use that one variable value because I have to move the two variable from n equal to 5 to n equal to 4. n equal to 4 was earlier 1, right? So I have to make 2 equal to 1, but I cannot update 1 before it. So I save the value of one variable in temp, that is n equal to 4, I have saved in temp first. Then I update n equal to 4, that is one variable. And then I update the two variable with the value stored in temp variable. And that goes on. That's how I'm using only two variables. I'm keeping the values of the two variables again and again, one of them in temp variable and overwriting the other one. And going on until I reach the very last cell. And when I reach the very last cell, that value will be my one variable again because I have gone from the n equal to 5 to n equal to 0. So that would be my one variable and I return 1. So I hope now you understand what I coded right now. I can summarize the code for you now. So in DP array, when I'm going backwards, I initialize only two variables, 1 and 2, where I save the last n equal to n value, like how many unique ways are there from that particular value to reach itself, that is 1, and the second last cell to last cell, how many ways are there. So both are 1, so I initialize them with 1. Now I run the loop for n minus 1 times because I have to update n minus 1 cells using these two values and sliding the window. And I save my one variable value in temp variable. And then I update my one variable with 1 plus 2 because I have to consecutively add the two cells again and again and move the sliding window. And then I update my two variable with temp. And finally I return 1 because that would be my answer after I have looped the entire range. So that's the entire code. The time complexity would be O of n. Space complexity would be a constant one since I'm using only two variables. I hope you understood the question. If you have any doubts, ask them in the comments here. If you like my way of solving the question, subscribe to my channel to get your daily updates for your daily LeetCode challenge. Thank you.